All right, so I want to just do a quick recap of the first section in 3.1, but rather than do it in a traditional way, since I'm actually teaching this in class, I want to show you a Delta Math kind of in my own little help session. So I'm going to go through and do some Delta Math questions, and then that way, if you're struggling, you can go through this and make more sense of it, kind of base it off of what you would have learned in class. So when you're given a system of equations, that means you're given more than one equation, and you're asked to solve it graphically, you have to do just that. You have to graph it. It's really nice working on Delta Math as opposed to working on a piece of paper, because then you don't have to worry about whether or not your lines graph straight, because the program will do that for you. So it's actually a little bit easier with the technology than it is to do by hand. So we're going to go through some that are all in slope-intercept form. We're going to go through some that are in different forms. I just wanted you to kind of see a variety in this video. So this one gives you two equations that are in slope-intercept form and asks you to graph them and then to see where they intersect, which will put our answer down at the bottom. So where it says solution, that's where we're going to put our final answer. So the first one has a y-intercept of -8. So I'm going to start at -8 on the y-axis. And then the slope is 2 over 1. So we're going to go up 2 over 1. That's going to be my first line. Now, if you graph a line and you don't like it, you can click on it. It'll delete it. You can start again. So you always have that ability to kind of erase in this digital format. The next one has a y-intercept of -2. So we're going to start at -2 and has a slope of -1. So that means it's going to go down 1, right 1. And what is really nice about this is, again, you don't have to worry about how good you are at drawing straight lines without a ruler or anything like that, because it'll do it for you. Your solution is where they intersect. So it intersects at the point 2, -4. So you want to enter your answer as a coordinate. So 2, -4, put it in parentheses because it is an X and a Y. Submit your answer, and you are good. Let me show you one more in that form, and then I'm going to look at ones in other forms. So this one is also in slope-intercept form. So I'm going to start at my y-intercept, which is -7. So I'm going to go to -7, put a point. And then my slope is -5 over 2. So -5 means I need to go down 5. This is going to be off the graph. That's going to be a challenge. All right, if you cannot do a -5, this is a good example to show you what to do. Instead of going down and to the right, I'm going to go up and to the left. So I'm going to go up 5, left 2. Notice it still has a negative slope. So this is a great example to show you what if you're kind of going off the graph. If you're going off a graph, when you go down and right, the same slope could be found by going up and left. So there's my first line. My second line has a y-intercept of -1. And then my slope is +1 over 2. So up 1, right 2, right 2. Again, if you don't like your line, you can always delete it. And it intersects at the point -2, -2. So we're going to go into our solution box and type in -2, -2 and submit it. So those were slope-intercept, which are often some of the easiest ones to do. So let me show you what happens if they are not both in slope-intercept. So let me show you kind of a level 2 question. So here's an example where one equation, the first one is in slope-intercept form, so we're going to graph it the same way we just did. And then the second one's in standard form, and we're going to graph it a little differently. So if it's in slope-intercept form, we're going to go to this y-intercept, which is 2, put a point. And then my slope is -1/4, so down 1, right 4. Make sure it is sloping downward, which it is. The second one, if it's in standard form, you have two options. One is to totally rewrite it and get y by itself and do the slope-intercept form if you're comfortable with that. The other option is to use the cover-up method and find intercepts. So I'm going to go with that. I think it's the easiest way in this, so I don't have to rewrite it. So if I cover up the y's here, I'm left with x equals 8. That means on my x-axis, it goes through 8. Got rid of my line. Hold on, let me get my line back. So it goes through 8. There we go. And then my y-intercept, when I cover up the x's, I'm going to have -y equals 8. So that means y equals -8. So I'm going to go down here to -8 on the y-axis and connect the points. So now my solution where they intersect is right here on the axis. That is the point 8, 0. So I'm going to type it in coordinate form, x then y, and submit. Let me show you another one that has standard form. Which one do I want to do? Will that one fit? No. Find another one. Well, that one's too similar to what we just did. Actually, let me show you this one because this is one that you might attack a little differently. So this one, your first one is in slope-intercept form. So you're going to start at 1. And then your slope is 1, so you're going to go up 1 over 1. Here's the challenge with the second equation. If you do the cover-up method, you're not going to get a whole number for your x-intercept, because if you cover up the y's, you're going to get 3x equals negative 7. When I divide by 3, I get negative 7/3. This program is not set up well to work with fractions, nor is it easy to do by hand with fractions. So if that happens, this one is actually easier to do by getting y by itself and getting slope-intercept form. So you're going to subtract 3x on both sides. You're going to start at negative 7. My slope is going to be a negative 3 because when this 3x moves the other side, it's negative. So from there, I'm going to go down 3, right 1. So I ended up graphing both of those with slope-intercept. They intersect at negative 2, negative 1. So I'm going to type in negative 2, negative 1, and submit. See if there's any other special ones I can talk you through. I think most of these are pretty similar. Yeah, I think that should give you a good understanding of what you're going through and doing. And then you also have special cases, which we talked about in class. The focus of special cases is looking to see if their lines are parallel. Then you get no solution because they never intersect. And if your lines are right on top of each other, that means they have infinite solutions in common everywhere that the line is existing. And that would be all solutions or infinite solutions. And that is how you do that section on Delta Math.